Hello, everyone. Thank you for joining us today. Today, we have a session on building, changing, and versioning infrastructure safely and efficiently. I will be talking about Terraform. My name is Hassan Mohsini. I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft partners and the open source community. It's also home to the Microsoft for Startups program. With a diverse mix of hands-on workshops, expert panels, and community events, there is something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. Our speaker today is Rory Preddy. Rory works in the developer relations team at Microsoft as a senior cloud advocate for Java. Cloud advocates use their deep research skills to help professionals and cloud developers discover and successfully use Microsoft's platforms. A seasoned speaker whose talks are both meaningful and humorous, Rory travels around the world empowering developers to achieve more. Keep the Q&A tab open as I'll be sharing some resources, and that's where you can send us all your questions during today's session. Rory has prepared the session for the Reactor community, so we'll learn together all about Terraform today, and it is listed as one of the, or the most actually, used infrastructure provisioning tool. Thank you, Rory, for doing this session with us today.
Thanks, Azam. Hi, everyone. And if you want to follow me on Twitter, you can do it at Rory Preddy, and also my LinkedIn profile on Rory Preddy. So what are we going to do today? We've got 45 minutes, and we're going to teach you Terraform in 45 minutes. And we've got 4 real agenda items, and then we've got a nice demo. And if you've seen some of my talks before, you know I like breaking stuff. So we're going to try to break some configuration, and then we're going to see how Terraform can actually fix that configuration. So we're going to go through is what is infrastructure as code. We're going to go through also the different components of Terraform. What is Terraform? How do you define your files? And then we're going to look at the workflow, the typical workflow that you follow when you run a Terraform project. And then we're going to do a demo and see if we can break some stuff and then fix. This is one of those sessions where I actually get to break stuff and then fix it afterwards, which is great. Okay, so infrastructure as code, hey, another buzzword that we get flown around, and this goes hand in hand with DevOps. So this session isn't on DevOps, but you can use Terraform for DevOps, but it's focused really on infrastructure as code. Now, what is infrastructure as code? It's one of those great interview questions where you can kind of work out whether the person has really struggled with infrastructure as code. And infrastructure code, I like to think of it as just, hey, here's some servers and here's some databases and configs, and we're just going to put them into code. And it uses a very similar syntax. If you've used YAML before, it kind of uses a very YAML-like syntax. It's not YAML exactly, but and then you define your code and what your intentions are. And then the nice thing about Terraform, this is really the novelty around this, is that it gives some element of change control. So if you've ever done change control, and I know that I worked in financial services company for 15 years, and you would go to change control meeting and they'd say, what are you going to change? What is your intention? And what happens if you want to roll back? And then you would have to give them a long printout of all of those items, and then you would say, okay, now this is what my intention is, though, and that really is what Terraform's about. It gives you the ability to go forward in time and also say what your difference is that you want to change. So what is infrastructure as code? And there's really few points. So stand up environments in the fastest way possible. So it gives you the option to create your environments quickly and painlessly. And I know, because for this demo, I probably have created my environments about 30 times. And normally I wouldn't even have the capacity to do that because it's just too tiresome. And creating a database, creating an app server, it's just, you remove the human element and reliably and repeatedly deploy each time. And it kind of looks at and it doesn't use AI, but uses a kind of an algorithm to say, this is the change that you need to do to get your system in the state that you wanted to do. And it improves the environment visibility and the developer efficiency because it understands state, and we're going to go through the state of your ecosystem, and it doesn't really rely on a developer to kind of have to go, wow, my server's in this state, my database is in this state, I'm going to roll forward, roll back, and it doesn't really. And then you can also, the nice thing is, store your infrastructure alongside your application code. So this project is actually based on a project that Julian Dubois created. If you don't know, he's part of the and the lead for the Java developer advocacy at Microsoft, and he created this. And all I really did was take this project, and I versioned it, and I made some changes to it, and it's in my Git repo now. And you can Git repo infrastructure. Yes, that's a novelty also, that you can version this and align it to your code. Because if not, and you want to have a server there, how do you know what your current server is running and version if you don't actually get your server? So this is a vendor product, and we've done this in conjunction with one of our partners, HashiCorp, and it allows you to write declarative configuration files in let me see if I remember that, in HCL files, in Terraform files, and we're going to look at that now. And you can plan and predict the changes, and it's a nice, elegant user experience for safely and predictably make changes to the infrastructure, and it's reproducible. It's reproducible. So if I want to create the same infrastructure on my PC as your PC or in a server, I can do that. And the nice thing also, it has some team kind of engagement. So I can store the state of my applications on a server in a storage, which means that you and I can both use the same server state and develop towards that in conjunction, which is absolutely great, because it means that I can reproduce your server state and the development server, the production server, the staging servers as part of a team effort. So we're going to be discussing one type of build pipeline, the Terraform pipeline, and we're going to be discussing the provisioning pipeline. Rory, there's three. Yeah, there's provision, build, and deploy. So provision means that I'm going to set up my infrastructure, and I'm going to then use it, and then I'm going to actually do my build and deploy with Maven. But you can actually do that with other tooling. But for the case of this exercise, we're going to assume that the IT infrastructure team has provisioned the subscription, the resource group, a VNet, a subnet, an express, VNet if you want. And then the infrastructure team is going to actually use Terraform to provision the database, the cache, the Azure instances. And then the project app team is going to provision the apps and configure them. So we're only going to really focus on the provisioning section, and we're going to use Terraform for that provisioning section. And we're going to use HCL, which is HashiCorp configuration language, to do that provisioning. And the nice thing about HashiCorp provisioning language, it's very similar to YAML, and we mentioned YAML before that. And it uses interpolation. So if you can see here, the Azure resource group there is actually, you can interpolate it. So you can go Azure resource group .web.0.id. That's in Terraform version less than 0.11. And then in Terraform 0.12 and later, you can just kind of use a plain syntax like they've got there. And then you can kind of interpolate it and use meta arguments, depends on count for each provider, lifecycle, provision and connection, to have almost a scripting language inside your HCL. So it's almost a high-level language, and I'm a developer of 25 years now, and I remember VB scripts, and Hazem will also remember that also. And VB script and Action script and all of those scripting languages allowed you to write all of these nice scripts before JavaScript came about inside your browser in a high-level language, and it really allows you to do that with HCL. So you've got your HCL, and you can deploy your resources. And then we also start to look at the language of the HCL, so we can better understand that for the demo that we're going to do, how we're going to position that. And the first thing you want to do is create your variables. And in the example that I'm going to create a little bit later on, I really only have two variables. I have a resource group and then an app name. And this example over here, you can see here, I've got the module, which we're going to go through, and then I've got name, resource group, and location with the variable details. With the HCL there, you can see var.vault storage name, and then also the resource group, the resource group.storage.name. So you can actually use nice interpolation, string interpolation with that to get those resource groups and the variable names. Then you also have functions, so you get high-level functions. You can also define your functions, though. You get all the normal string and math and usual count functions, and then you've also got conditional functions, and then the ability to define your own functions, where we're going to look at a little bit later. Then you've got provisioners. So provisioners are very interesting. You shouldn't really use them because you're taking away the power of Terraform and its local executions, remote executions. So you can still do bash scripts and PowerShell scripts using provisioners, but you shouldn't really use those because you should try and use what the actual Terraform scripts intend to do. Then you've got your modules, and they're reusable template code, and then they're the containers of resource. We're going to go into that a lot more detail there. You can see here in that module we've got vault storage, which is really what we're trying to do is we're trying to store in a vault for our product accounts some usernames and passwords. So that's the first example there of how to create a Terraform vault. A vault using Terraform, and then you deploy it into your production environment. So so we've got variables, functions, and then provisionals and modules. So the next is that we're going to go through this. Is the bane of my existence is state. And you'll see why, because state actually is this marvelous thing. And what state does, if you know the Venn diagram and you've got the overlap between what is and what your intentions are, and you overlap the two, state really does that. And it's responsible for mapping what your intention is to a real world state of a resource based out in the cloud, and then it tracks the dependencies between the resources. So if you want to create a resource, what do you need to create them and the dependencies, and then the ability to pass in previous deployments as parameters, and then it monitors the state. Now you can keep the state locally, which is on my PC, which is what we're going to do, or you can keep it in storage. Now, if it's in storage, it means that another developer can connect to that state and see exactly, and you can create your applications in conjunction at the same time as other developers. Wow. So that means that I can push a database change and I can see you pushing the same database change and inherit that database change. So as soon as you do that, I can get that database change working locally, and then if necessary, go and push that change into production. It enables you to work in the same ecosystem as your team at the same time. Then we have providers, and we've touched on providers a little bit. Now we have the provider of choice, which is Azure, which is this entire talk is on there. But we also have Kubernetes, Docker, VMware, all the other clouds. And the providers are usually created in conjunction with the vendor of choice. So Terraform would call, Azure, go dring, 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 dring. Hi, I want to create a provider with using your fabulous cloud, and then they would sit and create that ecosystem around that. You've also got in providers, resources, databases, file systems, data sources also, your URLs for your data sources. Next, we have, and we're going to deep dive a little bit into modules. So modules is a set of configuration files in a single directory. Think of it as your project. So we're going to create from scratch a very simple module, and we're going to create it in a single directory, and it consists of a single directory with one or more TF files, so Terraform files, all written in HCL. And you can see here in this example, there's a minimal module example there. You've got your README, your main.tf, variables.tf, and then outputs. So, and we're going to go through a nice example there. Also, main.tf is your functions, your logic for your application that you're trying to do. It also defines all of your dependencies and the resources you can create. Then you have your variables. So in our example, we're going to create just two variables, which is the resource group and the app name. And then you have your outputs. You want to see some outputs and you want to print out, and you can also pass outputs to different programs. So that's the norm, the minimal application you want to create. And there's a lot of best practices and why modules. Modules allow you to organize configuration, encapsulate, reuse, and consistently ensure better efforts. And there's so many different ways to actually do this. And I've got some nice examples later on that I give you in the Terraform Git repo that give you so many different modules and examples for everything that you ever want to do, not only Azure, but there's so many different other examples that you can do. So let's go a little bit more into state. So state is required for Terraform to function, and I've lost my state so many times because I at the time I didn't actually understand how state works. I would go into my Azure resources and I would like start using Terraform, and then I'd go, I want to change that and delete it there, and then delete some state there and delete that, and eventually Terraform would go, something's wrong here. I'm looking in the cloud and someone's messing with your cloud, and I didn't understand how it worked until I really put my faith and love into Terraform, and I said, you manage everything there. But we're going to break some stuff later on. We're going to destroy some resources and get Terraform to manage it. And then you can also see what the intended state is by using terraform.plan. So when you do terraform.plan, and we'll run it with the demo, you can see, wow, the state is going to change. Tell me everything that you're going to create, so I can kind of prepare for that. And then you can also do, once you've got terraform.plan and you like the state that you're going to bring your system into, you go terraform.apply. And then Terraform apply says, here's the difference that I'm going to apply. Go actually use the provider and create that state for me, and go create those resources. And the nice thing about using Terraform on my Macintosh laptop is that it uses my Azure CLI. If you're going to use GitHub Actions or Azure Pipelines, you need to still also create your credentials. So when it creates that state, it can actually log in with those resources. So let's go through a little bit more each of those files. So we've got main.tf, which is a required file. And this is your main structure in order to deploy your infrastructure or through calls to modules. You've got output.tf, identify each return value of a Terraform module. Then you've got terraform.tf vars, so assign values to variables in a file instead of arguments in a command. You can see there that's terraform.vars. So that's a nice way to also assign values. Then you've got variables.tf, which we've mentioned before, defining your variables. And then we've got something also called versions.tf, and that's define the minimal version required for Terraform and providers in a module. We're not going to use version.tf because we're going to use a really basic example, but this is a nice way to say, wait a second, you're creating a MySQL database, you're creating an Azure app service. Please use this version of these dependencies where you're going to do it. And this is really similar to Maven or NuGet or NPM, because it allows you to version control all of the different providers that you're creating. So let's go into another example. So I've got an example that we're going to create a very simple resource group, and I've got my main.tf there, and I've got my resource, and you can see there I've got my name of my resource there, and then I've got my name and location. So var.name and var.location, and I'm creating my variables by defining var.name and var.location. I'm actually defining the local variables for each of those. Then I've got my tags. So I tag my resource group there for environment and department, because you should always tag your resource groups, because if someone deletes it, that angle costs it, you want to do that. Then I've got my output.tf, and you can see the output.tf there is actually defining the printout. So the output is going to say resource group name, and it's going to print out the resource group that I just created. There's also just the resource group ID, and it's going to print out the resource group ID. And you can see there that I've defined it in HCL Azure rm_resource_group.rsg.id. So that's pretty simple. I've created a resource group, and then I'm going to create an output, and I would actually go in and go terraform.apply, and it would just create a resource group for me. I've also got my TF var files there. So I've got my location, my name, and my environment and the department. And you remember, it pulls in those environment and departments in the location.name. And then I've got my versions.tf and the required version 0.12, which is a newer version of Terraform. Then in my variables.tf here, I've got location, name, environment, and department. And I define the variable types, the string and the description. So you can see the variables.tf is really around defining each one of the variables, but you want to use the terraform.tf vars to set up your variables. It's almost like an initialization. You can also initialize as the default value here in variable, but the suggested way to do that is to use terraform.tvars. And in your structure, let's go through, so this is the full example here. So we've got our provider, Terraform, data, locals, resource, and then the module. So let's go through each one by one. So in the provider, and you must remember that the provider is Azure or a database. And I've got here the provider, Azure RM, which is the resource manager. And then I've got the version there that we're going to use. And remember, you can use versions also. And then under Terraform, required version 0.12. Under data, so data, if you remember, is defining your data resource. And in this example there, we're defining a test RG under data. Locals here, so this is the local environment, so location. And you can see there, I've got some nice, wow, that's my, I didn't even know I have a landline in here. That's my landline, but don't worry, that someone will realize that no one should have a landline at this time of the, the digital disruption. Then I've got my resource group there. I define my name and location, and then my modules that I've got, the source, location, and the module is pretty nice because it brings everything together. I've got my source, my resource group, my location, my storage account name, my storage tier, my replication, my description, and my environment. So that's really a one-stop attempt at defining all of the variables. You've got your providers, Terraform, locals, resources, and your modules. So once you've got all of that, now you can start looking at your workflow. And the workflow is pretty simple. The workflow is what I have, what do I want, and what do you need to do? So it goes through init. So initialize a working directory with Terraform configuration files. And that really defines a local version of your state files. So if it says, I have nothing in my state and I'm going to start from afresh. Then I've got validate, so it validates the configuration files in a directory without checking remotely. What it really does, it says, okay, I've got my configuration files. I'm not going to check the resources out there, but I just want to kind of confirm that all of the Terraform files are in a good state. Then I've got plan, so it creates an execution plan, i.e. what if. So then it actually goes remote, looks at all your resources, analyzes what the delta is going to be, the difference between the state, and then says to you, what are we going to change? Then apply, changes deploys the changes required to reach the desired state, and then destroy, my favorite, just removes the Terraform managed infrastructure. It deletes the state also in your Azure cloud. So destroy is pretty spectacular because normally when you see a talk on Azure, they say, please make sure that you delete your resource group. Now with this, I can just go destroy and it will just get rid of everything. But you can also with destroy, not only destroy one resource group, but you can do one resource at a time. You can also go apply and create one resource at a time also, which is what we're going to do in our demo. Because I don't want to spend my entire afternoon trying to create my Terraform resources, I'm going to destroy one item. I'm going to do a plan and see what the delta is and what it's going to do. And then I'm going to do a Terraform apply, and it's going to go, wow, you're missing this item. I'm going to go create it for you. And then we're going to see how the delta works in that regard. So that's all the slides I wanted to show you. And now we're going to go through our demo, which is pretty nifty. The demo takes about 15 minutes because we're going to go create some resources. You can access the demo on https:/aka.ms/t-java. And that's that nice repo. And there's a branch of the Spring Pet Clinic. So what is the Spring Pet Clinic? Now, this is an application that creates a MySQL database, a firewall rule, an app server running Java, because I am a Java advocate. Then it also creates all the necessary config to run the application server, the port configs, the always on, all of that configuration, and then creates the kind of the ecosystem around that. But it doesn't deploy your application. Once we've got that, I'm going to then show you how to deploy it with the Maven deploy plugin, and then deploy to that ecosystem. So yeah, let's start on that. I've got my slides here. I'm just going to minimize my slides here. So I've got my project here, and the project, if you go to your ecosystem, let's open up Google Chrome here, and we want to make that bigger. So if I go to ak.ms/t Java, so this is the Spring Pet Clinic, and you can see there I've actually forked it from Julian Dubois' Pet Clinic. And then in the actual application there, it's using a branch deployed to Azure, and I've got a Terraform folder there with all my Terraform scripts, and then I've got my actual application. I've got my source folder, and we're going to go through that now. My POM, and then also my normal configuration. I've got a Docker Compose, and then a readme.md that you can actually use. So let's go through the application, and we'll see what it does before we start to dive into the Terraform configuration. So I've got my Visual Studio Code Insiders Edition. So let's go. We want to go Command plus to make it bigger, and then we want to do that to make it smaller, bigger, smaller, bigger, smaller. It's like my life is just zooming in and zooming out. So let's go close all of that. We're going to minimize all of that. Okay, great. So I've got my Terraform script. So let's go through the source folder here, and I've got my the main Java, and I've got my Pet Clinic application. It is a Spring application, and this is the nice thing about this. This is the standard Pet Clinic that Pivotal actually uses as their examples here. And I've got my Spring Boot application, so it is running Spring Boot. It's not Tomcat or any other thing. And then either under owners, if you know this application, owners really is the core of that. So you define your owners here, extends person, an owner has multiple pets, and an owner does vet visits there, and you've got your one-to-many, which is your Hibernate. Rory, are you using Hibernate? Yes, I am. So under the model here, you define your person, which is a mapped class, and then your column here, and you define that with also a Hibernate config folder, config file here under your persistence.xml under resources. So under DB here, we've got our application.properties, and I can use an H2 database if you don't want to use MySQL, but I really want to use MySQL, and I'm going to show you MySQL. And then I've got also application MySQL.properties, and we're going to swap, when we actually deploy it there, you'll see that we actually swap over to MySQL.properties. And then my database here, I've got my MySQL.database here, and I create my database with data.sql, schema.sql, user.sql, which means also in this demo, it's going to take a little bit long if I create the database, because I have to go and create all of that information. Yeah, you're stuck with me for half an hour, which is great. And then we're going to create all of that underlying entities in that database. I've also got under my main folder here, I've got my web. So under resources, under static, I've got some nice templates here using, I think it's Timeleaf. Yes, Timeleaf, which is a nice kind of ASP.NET JSF format. And this kind of gives the view that we're going to see with the application and to manage our underlying data model. So you can run this locally, and to run that locally, you can actually go in and let's show you how to run that locally. So you can actually go into where's your and I want to run that under Java Spring Pet Clinic. You can just right click and you can go run locally, and this should actually start up. And now it's going to complain a little bit if I've set it up to run with my my database, my local database. So it's going to run built with Spring Boot, and then it should actually create ideally the H2 database, or if I've left it in a bad state, my MySQL database there. So this is it running locally. Okay. That's great. Demo worked. It's running H2. I just saw there. So then it started the Pet Clinic application. So let's go into localhost 8080, and you've got your Pet Clinic application, and it's not lining the style sheets, but you've got all your applications, and this is running locally with the database. So this is a great way to show how you can do this. And now I'm going to swap over to MySQL without changing anything, and I'm going to do that also with Terraform. So I've got my application there, so let's actually close that there, and then I want to stop my application there, and let's close that. let's close the debug. So this is how you run it locally. Now, if you remember with the H2, how it's doing that under system, sorry, not system, it's going under do resources. It's just picking up that if you have under your application properties, that if you're using the application.properties there, you're going to use the H2 database. But if I swap over to application.mysql, it's going to use MySQL. So all I have to do really to tell it in my Terraform is to use that application.mysql properties. And let's see how we're doing that there, because we're going to now look at the Terraform scripts. So I've got my pet clinic application there, and I'm into my Terraform folder there, and I've got my main.tf. If you remember, that's where all the magic happens. My outputs.tf, and then my variables.tf. Now, if I go in there, I'm going to do something pretty destructive. I'm going to delete everything. Delete everything and start again, because I want to go through with you exactly what we're going to do. So I've got everything there, and if I ran this now, it wouldn't work. But let's define variables.tf. So I'm going to close everything else. Now the variables.tf, we want to just define our resource group and our app name, because that's really the only thing that if you created on your PC, what the changes would be. So we're going to define there, and with the magic of snippets, let me just start my snippets up. With the magics of snippets, I'm going to create my Terraform scripts there, and I've got that there, and I've got my resource group, my application name, the location, US West 2. I love US West 2 because it's actually kind of like a DR environment. I always get what I want out of there. My resources are created. It's really prioritized. Use US West 2 if you really want no hassles and you want to guarantee that your resources are created. And then I've got my MySQL master password. You'd obviously use a key vault for this. For this demo, it's sufficient. And then I've got my MySQL password. So I've got my resource group, my application name, where I'm going to create my actual location, and then the MySQL password. My watch is actually telling me, look at my watch, it says inactive for over 1 hour. You know that this is one of the most demanding things that I've ever bought, this little fitness tracker. It just won't leave me alone. So I've got my variables.tf. So let's now also define the outputs that we want. So in the outputs.tf, I want to know where my resource was created and the names of the application server in the MySQL database. So I'm going to define that there, the output there, so the app service name, so I can actually click on it and know that it was created, and then the host name. So when it actually creates the host name, and you can see there in the host name, it uses HCL to go Azure RM app service.main.default site.hostname. So it's only those two variables. So when we create our Terraform environment, then we're going to want to look out for that. So let's go into now our main.tf file. So main.tf file, and I'm going to just make that a little bit bigger there. And I want to go create it. So the first thing we're going to create is we're going to create our provider. We're going to define our provider, Azure RM, so the resource manager for Azure, done in conjunction with the partnership with HashiCorp. And the version we're going to do there is 1.32. The resource group there that we created, we're going to define it as the var.resource group that we define in our variables. The location also there, and we're going to create that resource there under that. Now, just doing that resource group is going to create a resource group. Yeah, I know that's it, which is great. And then we've got a random password that we're going to create there, and that's it's a nice little function that you do there. So calling random password is going to create a random password. So the next thing after doing that, I'm going to go and create my MySQL database. So I'm going to create my MySQL server using the resource group and give it a name called resource group and then MySQL.server. The location, which is the location of the server, US West 2. The name in the resource group, the SKU, which is the size of it. It's quite a small server. Capacity 1 CPU, basic tier Gen 5. The storage profile, so where it's and what storage it's going to use, and then the administrative login, and then you can see there the random password, and then I'm going to disable SSL. So I've defined my MySQL server, but not my MySQL instance. So remember, you create your MySQL server, and then you create each one of the underlying databases step by step. So we're going to create here our MySQL database. So we've got our MySQL database, and it's the char set, the collation, the name of it, and the resource group. Then under the resource, we're also going to create a firewall rule. Remember, it's secure by default, and we're going to say please access 0.0.0.0, which is all underlying internal Azure resources. And we're going to access this via app service. We're not going to access this via SSH or FTP, so that's fine for our firewall access. So we've got our actual server there, and then we're going to create our app service plan. So we've got our firewall rule, and we're going to create our app service plan. Now, remember, with Azure, you create a plan first, and then you create multiple web apps associated with each one of those plans. And your plan is your underlying, think about it, your underlying tin, your server, and then you can kind of bolt on web apps there, and you can bolt on many different types and number of web apps, because you've got underlying that performance. And that's something that differentiates us from some of our competitors, because that's something that we started from the beginning to say we really want to give the developers access to all of the underlying compute power, not just have a server per application, but one server, and you can have multiple applications there linked to your app service. And we're going to use Premium V2, which is an awesome, powerful server. I think it's like 4 CPUs, 8 gigs of RAM, and I'd strongly recommend for anything Java, just use the Premium V2, because it's really got enough oomph to give you what you need there. And then finally, after that, we're going to go create some app settings. So we're going to create our app service. So we've created our Premium V2 there. Now we're going to create our physical app service. We're going to use Java JRE8, always on true, which means that it keeps it warm for us. And then we've got some web service, some app service settings there. We're not going to enable storage. And then we've got Spring Profiles Active MySQL. That's where we set that variable to actually use the profile for the application servers. So now our servers knows we're not using H2 locally, but we're using MySQL. So we can go in and deploy this and run it locally, and which is a great way of doing that. Now, the data source URL, we're going to go MySQL. We're going to pull in the Azure MySQL URL there, and the database name, the character encoding, and the SSL auth, the database username, which is the administrative login that we defined, and then the database data source password that we created. So just again, so we created our provider and our resources. We then went and created our variables and the database. We then created our database instance and our firewall rule, and then we created our app service instance and our app service plan, and finally we created the variables and the actual app service instance with Java 8. Whew. Yay! Okay, cool. So let me just make sure that my Git is telling me that we didn't do anything silly. I just got some extra. Let's go bang bang bang. Okay, cannot in read-only mode, so that's fine. And it's a nice way to in demos to make sure that you haven't really broken anything to check Git. My variable names, so that's also great. Everything's fine. So I should be able to. The demo gods are shining. Go in and then we'll go through the POM and the Maven settings once you do that. So in this example here, I've created my database beforehand, because the database takes about 5 minutes. I don't really have time to do that. I've created the database already, so I'm going to show you how to break your instances here. So I can go Terraform plan, and I'm going to show you here when it goes Terraform plan. Let's go Terraform. Yeah, I'm in my Terraform directory, Terraform plan, and I've deleted my app instance in this example. So I've got everything. I've got my database, I've got my resource group, I've got my application plan, but my app instance I've deleted. Now I want to go check this thing. This thing should be clever enough to say the only thing I'm going to create now is my app service plan that you deleted before the demo. So it's going to refresh state, and it uses the local state, so it uses the TF state file. It goes and analyzes everything, my database, my app service, all of my storage, and says, this is what we're going to create as part of this instance. And it takes a little bit of time while doing that, because remember, it's going out to the wild internet, going locally here also, reading all your files, and it's analyzing everything that you do. Now, if you want to see what it does, you've got a file here called TF state, and the TF state analyzes this in kind of a YAML format, and it says exactly what you need to do, and then goes in and calculates the delta that it wants to actually go in and create. So let's go look there. Oh, sorry, I should have actually deleted it before. So we're going to go delete it. So I haven't deleted it there. So I'm going to go Terraform. So I'm going to go Terraform, and I want to go list state list. This is going to list all of the things I created, and then I'm going to go Terraform, and I'm going to go destroy. Oh, this is disruptive. Destroy, and I'm going to go I want to delete that. This is always on live demo doing this on. Okay, destroy that, and I'm just going to go, and this is the in my instance on my profile, and it's going to go state destroy. And I'm going to go destroy. Let me just go find out. I did this before, so it's always a nice thing to have known that you did this before. Apply, state list, state rm, refresh, and wow. Okay, so let's just go no such file, all that. So let's just go Terraform plan. We did plan there. So we're actually going to, because I can't actually delete it. I forgot the command for that. So let's go Terraform, and we want to go destroy, destroy app.service. Let's just try that. Where are we here? Okay, so let me show you how to do this from scratch. Then I'm going to destroy everything. So let's go Terraform destroy. And destroy. Hazem, how are we doing for time? Because I'm about to destroy my entire instance.
Well, we got time. We got time, and we got plenty of questions as well from the community.
Okay, so we're going to go violent now. I've got the command to actually destroy one instance. Now we're destroying everything. So that's going into my resource group, and it's just going to wipe clean everything that we defined in our tier files, my MySQL database, all of that is going to actually go and delete it, which means that we may run out of time when actually deploying the application. But it's a nice way to show you how to start completely from scratch. And then it says, okay, cool. Do you want to continue, destroy all resources? And it gives you the state here. So we're going to destroy the random password, the resource group, the SQL server, the rules, the databases, the app service, and then will be destroyed, and it analyzes the delta there. So I think we're going to run out a little bit of time now, so we can actually go no there, because I'm going to show you how to do this a little bit easier. I'm going to go destroy it on my server. So I've got my portal here, and I'm going to go into portal. I'm just going to delete that instance manually there, which is not ideal. You should really remember what I said to you in the beginning. You should actually just trust Terraform to actually go there. So I'm going to sign into my portal. I'm going to delete the app service there violently, manually, and then I'm going to go into that and do the state apply, and it's going to just go create my application for me. So here's my portal, and this is not ideal because you wouldn't really take the power away from Terraform, and it's going to calculate the states again and work out exactly what the state changes there. Welcome to Azure. Wow. Okay, let's go there. So I've got my PayClinic application there, and now I'm in my app service, and I'm going to go in there and delete it. So yes, type the app name, and I've actually got the application. So just before, if everything goes wrong, so I've already got the application working there, and I've deployed it previously. So yeah, point proven. So and then I'm going to delete it there, and then I'm going to go and do that Terraform apply. So delete app service. I'm going to go no. I want to leave the plan, and then it's going to just delete my Spring PayClinic app application. That's pretty quick to do that. Now I can go into my Terraform script here, and I can go Terraform plan, and it's going to go and let's just wait for that to finish there. It's going to go check that it's deleted. Now, if I go Terraform plan, it's going to pick up that that's deleted. Now it's going to be clever enough to say, I'm going to go and recreate that application, because it knows in the state. It's managing the state locally. It knows what is created, and it's going to do a delta between them. Now, if I was running this with multiple team members, I could actually keep track of each person's local state, their remote state, and what the service state is also. So changes to apply. You can see there, it's picked up that the app service is not found, and it's going to go create in my app service. It's going to create app service.rmain will be created. Wow, that was quick, hey? And then I can go Terraform apply, and it'll create my app service for me. And then once this is finished, just take some questions while this is happening, and then I can just do Maven Azure Web App Deploy, and it'll deploy my application while this is running. So Hazem, let's take some questions, and then I'll once this is running, we'll go back to it once it's finished.
Sure. So one of the first questions is about how easy or difficult it is to get familiar and master the HCL syntax.
So I think that if you come from a YAML background, you know, a lot of things are written in YAML, well, the world actually is written in YAML. Kubernetes and Docker, and a lot of them have that YAML syntax, then you would adopt it very quickly because you're used to infrastructure as code. Kubernetes is a really great example in that regard. Docker also, if you've defined that, if you're a high-level programmer who's always been, you know, really creating multi-tiered applications using pairs, then it's going to take a little bit of time to actually get used to that. But it's a very well-documented ecosystem with a lot of nice templates. So I've got some nice examples that I'm going to show you a little bit later that you can actually go in and use the reference points from that.
The fitness stalker is still beeping. We've been super active, Rory. It was an
amazing.
This was
my timer. Hey, it's already given up on me. It's already said, like, you know, this thing has made my self-esteem so low. But I've actually got some gym equipment there just to remind me every time that this thing goes there, I quickly go over there and do some stuff just to shut it up.
All right, we got a question. That demo we've been using SQL Server. Can we also be using MongoDB in our projects?
Cosmos DB, yes. So we don't use like a plain white labeled MongoDB because MongoDB is open source. So you wanna provide an instance of that. So we use Cosmos DB. So if you're going to use it on Azure, then you can use Cosmos DB with the MongoDB library connection. So MongoDB, you can actually use SQL or Cassandra. I think, yeah, Cassandra, and then also the normal NoSQL instances though. So you can see here on my screen, sorry, just to interrupt you, it's created my app service that I've got here. You've got there, so we're going to come back for questions now. And if I go into my app service, it shouldn't have anything in there. It should be completely blank. Yeah, completely blank there. And I'm just going to quickly go in while we take a few more questions. I'm going to go, let's see where we are, CD, and then I'm going to go Maven. And I'm going to go Maven. There we go. Azure Web App Deploy. I've already set up the POM file for the resource group name. You're going to have to you have to do that on your POM file if you're going to do that, and then it's just going to deploy it Azure Web App Deploy. And so let's take a few more questions while this is running, please, Hazem.
So the question on the runtime, what is needed to run these scripts if you want to ship the Terraform scripts to some remote machine and run it there? What prerequisites are needed?
You do need Terraform running locally, and it's as simple as just a jar. So Terraform needs to run locally. I've got Mac, so I just go brew install Terraform, and it just did everything for me. I know, I'm so spoiled. And on your Azure CLI, so your portal CLI. So if I go into my portal, so if I go into here, Azure App Service, I want to go. Let's go into portal here. So let's go to portal. So portal.azure.com. If you go into your CLI there, it is installed by default. And then also if you're going to use Azure DevOps or GitHub Actions, it's also installed by default. So you can click here, and then I'm going to run bash, and then I'm going to just type in Terraform. It's really that's not the most difficult part of Terraform. The most difficult part of Terraform is forgetting that you mustn't delete things violently like I did there, and then go back in and your state kind of gets out of whack. Because a lot of times I did that in Terraform. I'll create my resources and then I'll forget how I deleted, where I deleted it. And there are some times where your state gets completely so out of sync, you have to go and manually remove your state. And that's Terraform state RM. And just like, you lose some files there. So if I go Terraform here, Terraform, it's already set up as part of the base CLI there. So everything's, if you want to go into that instance there, it's already set up for you.
That's great. You touched on the state and everything, and this was one of the interesting questions that also came as on using the same Terraform script for multiple deployments. So how can the state be managed and parameterized?
Well, first of all, you can put the state on like a storage bucket. So if you're running multiple servers there, you can actually keep that in a storage bucket. You can even version control that storage bucket. But the state really is an attempt to create a delta between what you intend to do and then what you plan to do. It's not really intended to kind of version control your resource group and your live resources. That's not the intention. Remember also we've got those provisioning pipelines. So we've got the 3 different pipelines that are defined. This really is just to provision your resources. You've also got creating your subscriptions and then also your applications. So you've got multiple different mechanisms around how to do that. It's on my screen here. It says that it's socket timeout. It will eventually come right. It's deploying the zip package to the application. So hopefully that will come right. Okay, so next question.
All right, we got a few minutes for more questions. Maybe I can remind everyone now that there is a survey for you to send us all the topics that you'd like to see at the reactor. The link is in the Q&A tab, and there is an event ID for today's session. So please use it.
Okay, let's actually go see if what our application is doing. There it goes, successfully deployed the application to there, and it will take a few seconds to start up. So let's copy that over and let's go to our application. It'll take a few seconds. We actually want to do that there. So let's just hit refresh. And if you want to, you can tail your logs. So if you go into your application, so now everything is created. It's in a good state. So if I wanted to version my files and check into that, I can actually do. And then I'm going to go into my logs, log stream here, and I'm going to see my application starting up. My Spring Boot application starting up. Remember, the first time that you create a Spring Boot application, it's going to connect to my database, and it's going to load all of my information into my database. So it takes a little bit, a few seconds to actually do that, starting live log stream, and then it's going to create that application. But what's interesting is that I deleted violently the application. I went in there, it picked up the state change, it knew what transition to do that, and then I used my other pipeline, my deploy pipeline, to actually go in and deploy my versioned application into my resource. You would actually do all three, create your subscription, create your account, all of that, and then you would go your provisioning, and then you'll deploy via GitHub Actions or Azure DevOps. So you would do all 3 pipelines and use Terraform as your provisioning pipelines. It will eventually come around. I did deploy the Spring Pet Clinic. Has there any more questions?
There are a few, but I'm not sure about the context because some of them came early on and maybe you covered most of them. Okay. So I'm encouraging the community to send us questions as we got a few more minutes before we wrap up, or else
you can see
that will be.
There's the Hibernate just pinging and doing a lot of work there. So my app's about to come up, and then drum roll, completed, and there's the Pet Clinic application connecting to my MySQL database that I used to create I've got all my owners there. It understood the Delta. I showed you how to run it locally with H2. I showed you all of the actual files underneath there. Let's go back quickly into our scripts there, play from start. So in summary here, we've got, let's go options, Zoom. We've discussed infrastructure as code. We looked at all the components for all the scripts. We did a lot of examples for those scripts. We looked at the workflow on how you can do plan and destroy. And then I've got some nice resources for you. For the docs, these are the actual Terraform docs, aka.ms/Terraform. It's all of the Terraform docs. For the examples, aka.ms/tfgit. And that's tons and tons of resources, samples on every single type of technology that you want to do with Terraform. So aka.ms/tfgit. The articles, so this is the docs, the Microsoft articles on how to get started with Azure Terraform. So aka.cda.ms, and you can see I created this because it's using a different system. It's 1QY, and that's the docs articles. And it's got some really nice templates, some tutorials, and then the code for the example that I mentioned, everything that I've done today, https://ak.ms/tf Java, and then follow me please on Rory Preddy. I do memes and also Azure updates. It's always a great place to see you on the Twitter sphere. And that's me, drop the mic, bam.
Thank you so much, Rory, for today's session and for sharing your experience with our community. It was a great session. And again, quick reminder for everyone, please take a minute to send us your feedback and all the topics you would love to see on the Reactor survey. Please use the event code that you see there. It's 12249 for today's session. You'll be required to use it there. And check out our calendar for more events and more sessions on various topics across the reactors. We will also love to see you on Twitter. The Twitter handle is MSFT Reactor. And Rory Preddy, you have to follow him as well for a mix of content all around Terraform, Java, Spring Cloud, and everything, plus lots of memes and beautiful demos. This session is recorded and it will be available very soon on our YouTube channel. So make sure you are subscribed to Microsoft Reactor YouTube channel. There is also a newsletter that we send out monthly, and you can be part of that newsletter by subscribing to the last link. I sent some links also relating to today's resources that Rory shared. So everything will be available as well on these links. And later on, when we put this on YouTube, the links will be there as well for you to go back to and check this as a reference. Thank you so much for joining us. And thank you, Rory, again, and goodbye, everyone.
Cheers, everyone.